Okay, we're starting to solve inequalities, which takes a lot of work. And the first thing we have to do is we have to move all of our parts to the left side. So that means keeping the x minus 2 x over x on the left, subtracting the x minus 4 over x minus 6, and what that leaves on the right side is nothing. We want that. We want to compare ourselves to 0. But I need common denominators here, so I need to multiply x's by the right-hand term and x minus 6's by the left-hand term. And if you remember something, we said to keep the denominators. Keep this factored and don't try to eliminate it or reduce it at any point. So I'm happy that I have x and x minus 6, that's on the bottom, but what I need to clean up is the top. And it's going to require some foiling. So on the top left, I'm going to get x squared minus 8x plus 12. On the top right, when I distribute x, I'll get x squared minus 4x. However, be careful, you're subtracting. So it means you have to take the opposite of those signs. When I do that, I'm going to end up getting an x squared minus x squared, so they go away. Negative 8x plus 4x gives me negative 4x. And 12, well, it has no other number to play with, so it's just going to hang out there. But you're not quite done. Your goal is to leave this in fully factored form. Pull out the common negative 4, and you're left with x minus 3. Watch your signs carefully. On the bottom, an x and an x minus 6, less than 0. You have to show that cleaned up step. That's what you want. One term fully factored on the left. Now we're ready for sign analysis. This is going to send, since there's 1, 2, 3 x's, a 3, x by itself sends a 0, and x minus 6 sends a 6 to the number line. And now I have sign analysis to do, and this takes a lot of work. I have split the world into 4 different sections. And because there's a big division bar here, I need a big division bar in my work in 4 areas. I also need a negative sign because I always have a negative 4 on the upper left-hand side. So let's compare ourselves to different variables. Say I focus on the 3. The 3 number came from the upper right-hand term. So if I look to the left of 3, I'm going to put negative signs. If I look to the right of 3, I'm going to put positive signs in that location. If I think about the 0 number came from the lower left factor. So when I look to the left of 0, I'm going to put a negative sign. To the right of 0, I'm going to put plus signs. And then I focus on the 6. The 6 number came from x minus 6 on the bottom right. So when I look to the left of 6, I'll put negative signs. To the right of 6, positive signs. Let's go over that again because you need to see that. You focus on one of the numbers. I'm trying to pick that one up there. Sorry. So if I'm focused on like the 3, look to the left sign, do you see negative signs? To the right, you see positives. If I try to pick another one, maybe I'll try the 0. I'm just using this line so you can see to the left, I have a negative sign. Sorry about that. To the right, I have a positive sign. If I look at the next number, the 6, I'm trying to divide the world into different parts here. There it goes. To the left, I see negative signs. To the right of 6, I see positive signs. So that gives me the work that I can do the sign analysis off of. Positive over positive is going to give me a positive area. Oops. A negative on the bottom of a positive makes that section negative. Negative divided by negative is positive, and negative over positive is negative. These are my overall signs. This is what has to be shown. And in this problem, I want to focus on, hey, what do we want in this problem? If we want things that are less than 0, I want the negative spaces. And because there is no equal to sign, I'm working with a soft bracket the whole time. So if I focus on the negative areas, it's between 0 and 3, and to the right of 6. So I'm going to say 0 to 3 with soft brackets and union that with 6 to infinity. Now these sections for LCD and excluded, you could have done right from the beginning. You could have written x and x minus 6 from the original denominator. The excluded values line up with them. X cannot equal 0 when it's by itself, and x also couldn't equal positive 6. Some people like to look at this point, but you can also look here for these values. And also look for a conflict. Because x couldn't be 0, this has to be a soft bracket, and you can just double check yourself there. So good luck. Have fun.